Hey friends, we're going to knock out lessons 10 and 11 together in a really short video. Just two big concepts that we're looking at here. So be with me here in lesson 10. We're looking at beyond 2 pi. All right. All this is saying is that in lesson 10, we are not just locked into going one time around the circle and then stopping at 2 pi. We can keep going. Okay, so just like if you're riding a bicycle, you're not stuck with just going with your wheel looping around one time and then you have to stop. You can keep riding your bicycle. Just like that car on a racetrack can go around multiple times, so can we on the unit circle. Okay, so 2 pi is where we start to repeat though, right? So if we think about something like, you know, marking a point D on that circle, and how it would be 7 pi over 4. Well, we just need to think about what portion we're talking about, right? Pi over 4 is up here. 1 pi over 4 is here. 2 pi's over 4. 3 pi's over 4. 4 pi's over 4. 5 pi's over 4. 6 pi's over 4. 7 pi's over 4 is going to land us right about here. Okay, so that right there is point D. If we take it even farther, which we certainly can, right? Let's look at point like E, 5 pi over 2. Well, pi over 2 is up here. I know, because I'm looking right here on my nifty student packet. Pi over 2 is straight up. So if I have 1 pi over 2, 2 pi's over 2, 3 pi's over 2, 4 pi over 2, and then another 5th pi over 2, I'd be right up here. Now what we can do is we can tell that it is 5 pi over 2 minus 2 pi. 2 pi is a full rotation. And we can keep on subtracting 2 pi's until, which is full rotations, until we get to something within the unit circle. Right? So really what I'm thinking now is doing 5 pi over 2 minus 2 pi, or I just made that 2 pi over 1, so I can make them common denominators, right? Remember, we can't add or subtract fractions without common denominators. 5 pi over 2 minus, well, when we counted, we also had 4 pi over 2. Two ways to think about that. But maybe you just took the numerator and the denominator, multiplied them both by 2, and find out that we're doing 5 pi over 2 minus 4 pi over 2. It would be at the same place as 1 pi over 2. Okay? And 6 pi over 2, well, maybe what you're doing is thinking, well, 6 divided by 2. 6 pi's divided by 2 is 3 pi. And so what we would have is 1 pi here. 2 pi is all the way around the circle, and now we've got a whole extra 3 pi here at F. Alright, so we're not locked to just 0 to 2 pi. We can keep on going around and around and around the circle as much as we want. And so when we extend that past 2 pi, 10.2 just shows you that cosine graph, that before we were stopping right here at 2 pi, if we continue on the same scale, the graph will also continue on the same scale. Okay. Now I've introduced the word period before about how long it takes, or what our domain, our inputs are, before something starts to repeat. And for both of these, that period is 2 pi, and then it just repeats itself again by the next 2 pi. Alright, so coordinating points on the circle would make sense that we have a point here on the downslope at about 0.707, and it would be that same point shifted 1 period, so adding 2 pi to find that exact same spot on the next wave over. So this one is just giving us even some more practice about that we could look at how many rotations we're looking at. If we're more than 2 pi, like this one is more than 2 pi, we can think about that like 24 pi over 12, plus another 1 pi over 12, right? 24 pi over 12 is 2 pi, so that's 1 full rotation, and then another 1/6 of a rotation. Is that right? Pi over 12. Another 24th of a rotation. So 1 full rotation and 1/24th, because remember we cut our unit circle in our book into 24 pi pieces. 1 and a 24th rotation. It would be the same coordinates as pi over 12, because this is just 1 full rotation back to where we started. 7 pi over 3. Well, let's see. If I need 2 pi, that would be 6 pi over 3 is 2 pi for 1 full rotation. Plus another pi over 3 is going to get us to 7 pi over 3. Right? So 1 full rotation. And then this pi over 3 is here, not at another full rotation, but at a 1/6 of a rotation, right? 1, 2, 3, 4, 5, 6. So it would be 1/6 of a rotation. So we can keep on going. That you can take a look at our lesson summary. It's doing that same thing. It's again just saying, notice that each time we go through these waves, they hit at 2 pi in factors of 2 pi. I mean multiples of 2 pi. Lesson 11. Just like we could keep on going around the unit circle again and again and again and again and again and again, we can also go backwards around the unit circle. All that that's going to mean is that we're going to call it a negative radian measure. Okay? So if we have something, drawing another famous unit circle going on here. Normally we start right here and we would normally be moving in a clockwise direction. That would be a positive angle measure. If instead we have a negative angle measure, it means we're going to start right here and we're going to go clockwise. That's all that it means. So if I go, say, negative, I'll use this one here, pi over 2 radians. Well, pi over 2 positive means I'm going up to this point. Pi over 2 negative means I'm just moving in a clockwise direction. So this angle would be a negative pi over 2. Notice that that angle and its coordinates down here at 0, -1 is the same coordinates as if we had started here and gone in a positive angle measure. They get to the same place, they're going to have the same coordinates. So all of our coordinates at negative pi over 2 are going to have the same sine and cosine, the same coordinates. It's the same angle as if we had done a positive 3 pi over 2. If you're asking yourself, well, how do I get there from a negative angle? If you have a negative, you could just add 2 pi to it and get through 1 full rotation and land back into a positive number. You're like, wait a second, what is that? Say that again? No problem. We could take negative pi over 2. We could add 2 pi to it. That is just 1 full rotation. In a positive manner. Go in that 1 full rotation in a positive manner. Adding these guys together, well, let's see, I need a common denominator before I can add fractions. Right, so I have a negative pi over 2 plus I need something over 2. That would be 4 pi over 2. Negative 1 pi over 2. 4 positive pi's over 2 leaves me with 3 pi over 2. Bing, 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 bing. Perfect match. Okay. So negative angle measures just mean we're moving clockwise. Positive angle measures, as we've been doing so far, counterclockwise. And by adding a full rotation to any negative angle, we can find it as a positive angle. That's all that it's really asking us to do through here about this. Now we can start to see that cosine and sine, we are no longer locked into a cosine graph. All right, we've done it here now to 2 pi. And then in lesson 10, we saw that we could also continue this to 4 pi. But now it's also saying we can have negative angle measures. It's going to continue that graph. So I think I mentioned to you before that the cosine graph is an even function. It is reflecting over the y-axis. Okay, so this is why we can start saying, well, hey, this positive angle measure and the negative angle measure, they're equal to each other as far as cosine goes. Okay. Remember, cosine is our x-coordinate. I'm going to blow your mind here. Positive angle measure, pi over 6, has the same x-coordinate as the same negative angle measure down here. Right? And we see that because those are the same. So if those are that same, being reflected, oh, that's right, we're looking up and down here. That same that's in quadrant 1 with a positive angle measure would be the same down here as a negative angle measure in quadrant 4. Okay, so that's why these ones are reflective. Positive x, positive y, negative x, positive y. They're reflecting right on over at that same value. And in that same kind of way, we also want to look too, we also want to look too at what the sine function looks like going forward and backward. So if we think about that sine function, goes right through the origin like that, up, down, up, by the time we get to 2 pi, up, down, up, by the time we get to 4 pi. We can also complete the same thing with our negative angle rotations. Down, up, down for a negative 2 pi, down, up by a negative 4 pi. And what we see here is that this graph, sine function, is an odd function. It has rotational symmetry. So what we see here, that was a positive x, positive y output, would be able to rotate down here to a negative x, negative y output. Okay. So this is why what we're seeing, you would have to move an entire period over here, but this kind of sense that it's rotational symmetry, right? What's happening up here rotates down to here. And as we go negative, it's still that same negative rotation going on back here, right? So starting from a positive angle measure, just picking on 5 pi over 4 to get to this negative root 2 over 2, negative root 2 over 2. We're looking here, yeah, right about there. And so we're finding that that's happening in quadrant 3 going forward, right? So a positive 5 pi over 4 is going to match up to that same location when we're over here one period earlier, one full shift going on. But we can see that we have some odd functions, some rotational symmetry. That's our big ideas from lesson 10 and 11.